Hi guys, Mrs. Tilisin here. Welcome to another lesson of Algebra 2. Today's lesson is a continuation of how to simplify rational exponents. I do recommend that before watching this video, you've already watched the video about how to simplify radical exponents and the part 1 of rational exponents. Okay, let's continue. I have the fourth root of 9x to the power of 6 and y to the power of 4. And I would like to take note that my root is a 4. So my goal is to be able to cancel the 4. So I want everything that can work with 4. So let's see what do we have to do in order for us to simplify that. So let's simplify the 9. That's 3 times 3. So I'm going to work with, instead of writing 9, I'm going to write 3 to the power of 2. And then x to the power of 6, y to the power of 4. And we've already learned before that there is 1 of 4 inside the 6, right? So I want to rewrite x to the power of 6, taking out the 4 from it. So that is a fourth root of 3 to the power of 2, x to the power, let me change the color of that, x to the power of 4, x to the power of 2, because there's still 6, right? I still need to make 6 x's. And that's why I have to have x to the power of 4 and x to the power of 2. And then y to the power of 4. And that will make us, up here, the fourth root of, I think we can now put our final answer. So we have some numbers will go inside the fourth root. Some numbers will go outside the radical. So every time it works, it goes in. Goes outside. Every time it doesn't work, it will go in. The 4 does not really go to 2. So the 3 squared stays in. The 4 goes into that 4. So the exponent gets canceled and the x goes out. The 4 does not go to 2. So the x squared is in. This 4 goes to that 4 perfectly one time. So the y is going to be outside. Normally, right? Normally we would be done. That is our answer. But it looks like that the root we have right here has something in common with our exponents. Right? What do they have in common? They have a common factor of 2. Now, Miss, what if this was a cube? Then you don't have to simplify it, right? It's just that it happens here that the fourth root have something in common with the two things that are inside. So what is the common factor? Isn't it a 2? So what I'm going to be doing is I'm going to be simplifying it by dividing all my exponents and my fourth root into 2. And the ones that are outside will remain the same because they're not part of the ones that I need to simplify. Okay? So let's start with 4 divided by 2. That's 2. 2 divided by 2. That's 1. So you're left with 3. 2 divided by 2. That's 1. So you're left with x. So your final answer is xy. Because that's a 2, you really don't have to put 2 in it. You can just put a square root of 3x and you are done. That's it. Moving on. We have 8. 8 is 2, 2, and 2. So I have the sixth root of 2 to the power of 3. X to the power of 12. I'm going to break y to the power of 6, y to the power of 3. Okay? And hopefully, at this point, you know why I broke that. Equals, some answers go outside the radical, some answers go inside the radical. So the 6 does not really go with the 3, right? So the 2 to the power of 3 is in. The 6 goes to 12 two times. So you have x squared on the outside. 6 goes to 6 one time. You have 1y on the outside. The 6 goes to 3. No, it doesn't. So the y cube will stay inside. Normally, that would be your final answer. But because there is a common between your 6, 3, and 3, you are still going to simplify that. So what is common between them? Isn't it a 3? So we're dividing all of the numbers by 3. And again, as I have mentioned earlier, the 1 on the outside will remain the same. So you still have x squared y on it. So 6 divided by 3, you are now going to have a 2. 3 divided by 3 is 1, so you have a 2 in. 3 divided by 3 is 1, so you have y. So your final answer is x squared y. And then again, you don't have to put the 2 because a square root means a 2. But if you put the 2, it wouldn't be wrong. It's just that we normally don't put the 2. Okay, letter C. 64. What is 64? How many 2's are in the 64? Right? Let's do 8 and 8. That's 2, 2, and 2. 2, 2, and 2. So there are 6 2's that are in the 64. So what I would do is I would write that under the radical. 6th root of 2 to the power of 6, x to the power of 4, y, okay, I'm going to rewrite that, y to the power of 6, y to the power of 2. Okay, and that still makes 8y's equal. Some answer will remain inside the radical. Some answers will go outside the radical. So 6 in 6 goes cancel. So 2 out. 6 and 4, no. There's no 6 in the 4. So x to the power of 4. And 6 goes to 6 perfectly. Y out. 6 does not go to 2. So y squared in. Normally, let's put that together. Normally, you would be done. But because it looks like there is something in common between 6, 4, and 2, you can still simplify it. What's common? 2. So we're going to divide each of them by 2. So 6 divided by 2, let's write that down. 6 divided by 2 is 3, so you have a 3 in there. 4 divided by 2 is 2, so you have an x squared. 2 divided by 2 is 1, so you have 1y left. So your answer is going to be 2y, the cube root of x squared y. Okay, number 5, let's go. Okay, number 5, we have x to the power of 5 over 3, and we have x to over or divided by x to the power of 1/4. What do we do when we divide variables? Do we subtract the exponents? Okay? I need you guys to remember, when you divide common variables like same variables, x divided by x, y divided by y, z divided by z, because they have the same base, you will subtract the exponents. When you multiply variables, when you multiply numbers, you would add the exponents. Okay, divide means subtract, multiply means you add the exponents. So, because this one is dividing x to x, we are going to subtract the exponents. So let's do that. You have x to, maybe we'll put that really in the corner. So we have x to the power of 5 over 3 minus 1 over 4. I know I'm making it super far from each other. So this is x to the power of, They don't really have the same denominator right now. One is a 3 and one is a 4. So we cannot just subtract the number. We have to make them to have a common denominator. So what would match? Right? What do we multiply to 3 so that what is their common denominator? And that would be a 12. Right? So in order for this to be 12, in order for the 3 to be 12, I multiply 4 top and bottom. In order for the 1/4, the 4 to be 12, I have to multiply that with 3. So 3 top and bottom. Okay, so that is 3 times 4 is 12. That's good. 5 times 4 is 20. Minus, I have 4 times 3 is already 12. 1 times 3 is 3. So that is x to the power of 17 over 12. And my goal is to write your answer in an exponential form using positive exponents. So I do not have to rewrite this. My final answer would be x to the power of 17 over 12. But of course, you can always write that into a mixed fraction, but you don't have to. You can leave it as x to the power of 17 over 12. Okay, moving on. I have y to the power of 2/3, and then I have y to the power of 1/2 times y to the power of 3 over 4. I have already mentioned that when you multiply variables, you will add the exponent. So in here, there's so many things that we have to do, right? There are so many ways actually to solve this problem. But right now, I think it would be best if we concentrate on the bottom first, right? Because we are multiplying this y to that y, what do we do with their exponents? We add the exponents. So let's just do that first. And I am going to leave 2/3 untouched on the top. I am not going to solve it yet. I'm going to solve that later. So I'm going to do y to the power of 1/2 plus y to the power, maybe we could write it this way. Okay, we have there y to the power of 1/2 plus 3/4, because I am trying to solve for this first, and because I'm multiplying those two variables, I'm adding their exponent. I am gonna leave y to the power of 2/3 untouched on the top, and let's solve this one. So this is, what is their common, I think, 4. 4 would be their common denominator, correct? So I can leave this. Let's make that a little bit bigger. There you go. I could leave, what do I multiply this to become 4? I multiply it with 2, right? So I multiply with 2 on the top, 2 on the bottom. So that's 2 times 2 is 4, 1 times 2 is 2, plus, I don't really have to do anything with that anymore. So this is going to be y 2/3 over y to the power of 5 over 4. So now I am left with that, y to the power of 2/3 over y to the power of 5 over 4. Now what? What do I do? I am now going to subtract the exponents, right? So there are so many ways to solve this problem. And then you just noticed here that it might be taking longer if we do it that way, like we add the bottom first and we subtract, and that is taking us long time. Now there is also another way of solving it, one by like all together all at once. So I'm going to erase this, and I'm going to be showing you, like, miss, why did you show that if you're just not going to finish it? I just want to show you that way, the way I did it in the beginning, it's like a longer version of it. So what if we do it this way? So I know I am going to be solving y to the power of 2/3, right? And if I concentrate on this side, I know that this is, I'm going to subtract 1/2, right? So I'm going to subtract the 1/2 to that, or let me make a space. I'm going to subtract the 1/2 to that, and at the same time, this would also go up, so I'm also going to subtract 3/4. Okay? That is y to the power of, very long, I think maybe we can put y to the power. Let's exaggerate that the y is at the bottom. Okay, what is their common? 12. Okay, 12 would be their common denominator. So we are going to, let's see, multiply top and bottom by 4. Multiply by 4, multiply by 4. Multiply the 2 by 6, and then multiply the 4 by 3 and 3. There you go. So 2 times 4 is going to be 8, minus 1 times 6 is 6, minus 3 times 3 is 9, equals to y, 12. So what is 8 minus 6 minus 9? That is a negative 7. Oh, but you have a y to the power of a negative 7 over 12, and our instruction here is that we are only gonna get positive exponents. And we have learned before that whenever we have the negative exponent, we put that whole entire thing at the bottom and we put 1 on the top. So we do a reciprocal of it. So that's 1 over y to the power of 7 over 12. Okay, moving on. Last of number 5. Okay, so the top are 2 right here. The top is going to be x squared plus times x squared times x to the power of 1/3. So that means I'm going to add their exponents, correct? So that is x to the power of, I will just put 2 over 1 plus 1 over 3. And then you know how you have x to the power of negative 3/4? So that means minus negative 3/4, right? Minus negative 3/4. That means that's also a plus 3/4, right? Because you're going to have, or if you're not seeing it, again, because it's from the bottom, I'm going to put it on the top. That means you're dividing it, so you're subtracting the exponent. So I could be minus 3/4. Does that mean plus 3/4 then? So I'll just put plus 3 over 4. Okay. What is the common over here? Oh, 12 is very famous. So let's divide. Let's multiply. How do you make a 12 on this? Divide by 12. Multiply by 12. Multiply by 12. Multiply by 4. Multiply by 3. Okay? So we have 12 times 2. You're going to get 24 plus 4 plus 9. So you have 24 plus 4 plus 9. That is x to the power of 37 over 12. So our final answer is x to the power of 37 over 12. There you go. Okay, last one. Determine whether each expression is equivalent to, oh, this is a lot, 3x cubed 4 to the power of 4 over 7. Okay, first question is, who owns the 4 over 7? Right? I think it's important that we know who owns the 4 over 7. And I think because both of these are in the parentheses, the 4 over 7 is owned by 3, and it is also owned by this one. So let's give it away. And we'll see as soon as we keep maybe simplifying it, we'll see which one will match on this one. Okay, so the 3 to the power of 4 over 7, and then x cubed to the power of 4 over 7. Okay, there you go. So I think I can simplify. Remember the property which I discussed before? It's called power of a power. So if a power is raised to another power, you can multiply the two powers. So technically that is going to be 3 times 4, that's 12 over 7. Okay, does it match with anything? Nope, it doesn't. But there is a radical going on. So why don't we convert this into a radical? Remember now, the top tells you how many 3's you have. The bottom tells you what kind of root it is. The top tells you how many x you have. The bottom tells you what root it will be. So I will be doing 3 to the power of 4. And the root of that is going to be 7. And then I would also do x to the power of 12. And luckily, the root is also 7, so I can keep them together inside. So 7. What is 3 to the power of 4? That is 4. That's 3 times 3 times 3 times 3. That's 81. X to the power of 12. So far, do we match? Yes, we do. We match with this one. Okay, moving on. Is there anything that we can do? Can we still simplify? It looks like we can simplify the 7 and the 12, right? So how many 7 are in the 12? There's 1. So I could simplify that further by saying, oh, this is the 7th root of 81, x to the power of 7, x to the power of 5. Does that make sense? So we have the 7th root of 81. The 7 goes to 7 one time, so x up. The 7 does not go to 5, so you have x to the power of 5. So far, are we matching anything? Oh yeah, we have right here. And it looks like that these two doesn't work. Okay, there you have it. I hope that this video is helping you how to simplify rational exponents. Thank you, everyone. We'll see you guys in the next video.